They'd
Oh,
probably
by the
agree
way,
it's way too important. Okay,
Eve, do you have
yes.
Eve? Do you have my slides?
I will download them. Do you mean at the very end? I will get them in the interim. Okay. Why don't we begin?
Okay. Okay. So you want me to begin? Okay.
Yeah. Why don't you go ahead?
Okay. Hello, everyone, and welcome to this actually this last session of the week, which has been kind of interesting to have everybody in virtual. This is Computing in a Network, COIN, or three gems are Jeffrey, Eve, who's on the call, and me. Jeffrey is having major data tracker issues, so he may join us a little bit later. Next slide. We have the usual. So by the way, we are recording this, so do this. If you don't want to be recorded, don't talk. We have the meeting material. We have an Etherpad. And obviously there's the Jabber. The Jabber is also reflected on the chat for this session. We do not have a note taker right now. However, in another meeting, what we did, we used the recording to do the minutes. But if somebody want to take some notes and send them to us after, it would be really great. So again, the recording. I think with Meet Echo, to have the video off and to wear headphones is kind of easy. And again, keep yourself muted if you're speaking. And we are monitoring everything to see if there's questions or comments. Next slide. So this is the intellectual property. I think this group didn't have a lot of problems with that up to now. But, please read this and make sure that when you present something that you are very much in agreement with the IPR. Disclosures, I would say for me, the most important one is a timely matter. I guess all the problems that I've seen with the intellectual property has been intellectual property that was disclosed way later in some work where the work was very much advanced and it was very difficult to go back. Next slide. Again, it's privacy and code of conduct. We're also very much into that and making sure also that everybody's very respectful of one another and of also the whole meeting. Next slide. So this is, again, very generic. The goal of the IETF, I think it's the one that's highlighted, is the most important one. We do research. We do not do standards. So I think it's important to know that the work that is presented here, even those that are drafts, will end up in informational and not as a standard track. Next slide. So us, this is us, COIN. We have a very generic, I would say, goal, and I think it's evolving because this field is also evolving, but it's still very much the fostered research in computing in the network in order to improve performance, to improve applications, and to improve user experience. We're not very limited in terms of scope. We want to look at architectures, we want to look at protocols meaning everything from transport layer issues to security. And we want to look at real world use cases, application, and work in progress. And I think more and more in terms of architecture, we've been also associated with some new ways of looking at the internet. And officially, we're breaking the end-to-end paradigm. So, there's ways of looking at what we're doing. And I've seen papers in ANWR this week that actually have also addressed some of these issues. We want to, obviously, the focus, it's not a focus, but it's actually, it's not too focalized, but it's the focus. It's the core to edge compute continuum. And I think while computing a network really started with data center applications and services, we can see that more and more it is moving to the edge, and it's moving also with what I call the cloud-enabled edge, or the cloud supported edge, where you essentially have applications that communicate at both ends. Next slide. So we have a pretty dense agenda, and I've already taken too much time, but it's okay.
Yes, you're at the halfway point.
Yeah,
I'm going to be the timekeeper, and I'll try not to be too dictatorial, but I will let people know.
We'll look very fast at the drafts and the milestone lists, and I think probably for sake of time, we'll send the plans for updating the milestones, which we would like to do. We'll send it to the list, and we plan to have probably an interim where we could also do that. We're going to have a number of presentations. The first two ones are very much into requirements and directions from China Mobile, and then from Dirk and Jorg. There's going to be quite a bunch of data discovery, I think a very generic problem, then the edge impact of that, and then the mobile. Next is fine. The industrial use case, this is actually an update. And I would say from the previous 3 presentation, Dirk's, Eve's, and this one, I think we will probably start looking at adopting them as RG drafts. Then I don't have a draft, but we've done work with Edgar Ramos at Ericsson, Roberto and Ev on some kind of common data layer, and I want to express that, and we're probably going to have a draft later. And if we do have time, we want to have some discussion, again, approving some working group items in interim, the next IETF. And I don't think we'll have time for open discussion, but let's be positive here. Next slide. You want to talk about this, Eve? I think you should go to the next one.
Okay. This was
yeah,
I mean, this was just to share with people the drafts that are affiliated with the group at this point. And many of them will be presented today. And in fact, here's a different incarnation of that, showing the drafts that will be presented today. The red drafts are, the ones marked in red are new drafts. There'll be several that are also not going to be presented today. And then time permitting, we'll discuss whether or not the group is ready for discussion around adoption for several of the more mature drafts. Marie-José, I think you were planning to speak to this.
I was going. Okay, so I actually did a milestone review, and while we didn't have like real KPIs, like how we're going to evaluate where we are. So I think I will not go through the whole list. I think we've achieved or partly achieved a few. I think we need to basically address some of the implications of COIN. I think there's been discussions. There's been a lot of discussions, I would say, in the group and outside the group on the impacts, but we haven't really put them in concrete. So maybe this is something that we want to start addressing because I think it's still an important milestone. I think what we have been really good at is looking at what's happening in the landscape. What are some of the current applications? What are some of the challenges, because we needed that to get IAB approval anyway. So we've been pretty good with that. I think the last one, which is for actually the next IETF, is something that maybe we could start looking at, is working toward a better scope, actually scoping it better. Like I said, we started by being all-encompassing because we wanted to do the whole edge cloud continuum, but there's probably things that could stand out. And I think we would like to do that now. And also probably we will send that to the list. There's currently 70 people in the queue. I know there's more than that in the list, and maybe having suggestion for new milestones that should be changed. I don't know if you follow, but there's a lot of discussions about data filtering, for example, that would include Eve and I are really keen on that data filtering at the edge, and that goes with some of the work we've done that includes metadata, and essentially to have better function and data discovery. So I think we're going to send that to the list, and start working on that for the next IETF. And I would say where we are trailing is the catalog of COIN requirements and applications. I think it's hidden somewhere in a lot of the drafts and in a lot of the references that we have, but I've put that on my list of things. We don't go anywhere these days, so we have a lot of time. It's on my list, and I guess other people's list, of trying to address that. And again,
okay, we're at time. Just for your
okay, we're at time. We're out of time, and then we go to the first presentation. Perfect. Yes.
Okay, so I think we're gonna, because we're having so many technical difficulties. Let me see. Have I stopped displaying? How do I get the display back?
I think you can do stop displaying.
I know I can't seem to get that control. Oh, here it is. Okay. Stop sharing.
Okay.
Okay.
Are the people from China Mobile online?
Yes, this is Peng.
Can you please share your presentation?
Okay.
Because we are having technical difficulties.
Yeah, I'm having issues. So,
I'll find where to share my screen.
So at the very top of the screen, under your name on the left, there's a icon. There you go. Excellent.
Good. We see it.
Okay. Okay, can you?
Yeah, we see it.
Can you see my screen?
We can, and you can go into display mode if you'd like.
Okay.
To make it a little bigger.
Okay, is it?
Yes. Perfect.
Okay, let's start it. Hello, this is
Could
Peng from
you
China
speak a
Mobile.
little louder, please?
Okay, this is Peng from China Mobile.
Yeah.
Is that okay?
Good.
I will introduce a draft of requirement of computing in network and differential resource reservation. Yeah, and so first is the requirements. In last version, we categorized the requirements into network, computing, and management. The major change from last meeting are adding the requirements of the computing and management, including the computing resource reservation, computing resource OEM, and service consistency. And we also consider some existing protocol might meet the part of the requirement. Yeah, so the requirement of computing resource reservation mainly considers that some new applications like AR/VR motion control put forward higher demand of the network, and the AI is also considered to be used in the app and the network. So in order to satisfy their demands, network may not only need to reserve bandwidth resource, but also reserve computing resource. And there might be serial distributed computing model of computing in the network, and the different results need to be reserved from different nodes. For example, AI algorithm also has a model of step-by-step iteration at multiple nodes. The previous iteration will affect the next result, and computing results required for each iteration are not the same. And we think maybe the SFC also have the same process. So next is OEM, okay, which might be considered early, but what can be mentioned is that OEM of computing results is more complex than network, because network monitoring is relatively simple, like bandwidth, latency, jitter, while computing can be divided into many categories. different application need different kind of computing. So it need to implement a fine-grained VM or others to the results. And the service consistency refers to the multi-user access use case. It also comes from many existing applications such as games, remote video conference, usually multi-accessed and interacted by several users at the same time. This brings about a problem of the consistency. That is, users access to the same game or video need to have the same SLA, otherwise it will seriously affect the experience of the users. So the service consistency can be achieved through network management or application layer control. Yeah. So those are the added requirements of the new version draft. And next, we will introduce differential preservation. This draft it considers the problem of the computing, especially in the serial distributed mode. The calculation process of serial distribution algorithm is sequential, and the required result of the previous calculation need to be used in the later calculation. So it will bring the follows two problems. And different computing nodes on the same path need different reserved computing results, and the bandwidth results to be reserved may different after the previous calculate in the same path. So the typical example is introduced. Okay, sorry. Introduced previous as the picture shows. The task may be divided into three sub-tasks, and the network device 1, 3, and the server may complete a part of the maybe 20% and 30%, and the rest half of the computing task. So some existing protocol such as SVP and PCAP can be used to reserve bandwidth results. And SVP is a traditional protocol which only focus on how to initiate the reservation of results, not the establishment of the path. And it's same as SVPT. Yeah. And the PCAP was designed to separate the path calculation and the path establishment functions of SVP firstly, which means that the path calculation part before results reservation can be realized. So therefore, we say that the two protocols can be used together or separately.
Just a quick note, you've got a couple minutes left.
Okay, so we have two reference method. One is distributed resource reservation, and the process is as follows. It's just as RSVP, but we can be realized by defining a new object of RSVP. This example of it, we can add the bandwidth information for it. And the second is centralized reference method by the PCAP protocol, or we can realize by the netconf protocol. Maybe we can define a new YAM module to realize it. Yeah. So the next steps, we want that more analysis of technology and the research directions of requirement that can contribute to the RG, and we want to give more research directions to our work, and the overall discussion about the related trends and technologies also welcome. So if you want, if you interested in it, please join. Yeah, that's all. Thank you. Any comment?
Hey, hello, this is Dirk. Yeah, thanks for the presentation. So I just had a quick look at the draft again. And so it seems that you are addressing a very specific computing in the network scenario. And so from your presentation, I can kind of guess what it is, but I think it could be worthwhile spelling that out more explicitly in the draft, because other people may have different assumptions and different scenarios. So it's a bit difficult to talk about requirements in general when actually you may only be addressing a specific scenario.
Okay, so I guess let me just talk about the name. Maybe we can talk more about it, and if different people have different acknowledge about them, we can get more satisfied name of the model. Yeah.
Thanks, Dirk. Dave? And if you could be quick, that'd be great, since we're at time. Oh, Dave, did I somehow delete you from the queue instead of having you enter? Oh, he's back. Good. Okay. Maybe, Dave, you're having audio issues, or maybe I'm having audio issues. One more time. Dave, we are having technical difficulties. And Marie-José, I'm not seeing you either.
I'm not on Jabber, so you don't see me below, but I'm there.
Oh, okay. All right. Well, it's time to move on to our next presentation. Maybe we'll come back to Dave's question. We were having issues.
Maybe, Dave, you want to send your question on the... Oh, yeah, you are.
Okay.
I saw your question. Actually, Peng, you should look at Dave's question on the...
Okay.
And Dirk, are you wanting to send? I don't see
The
that
chat.
you've requested audio, Dirk. Okay.
So yeah, I agree with Dave's. Yeah, you
What
have
was the question? Comment? Okay, Dirk, I think you've got video, shared screen, audio. I think you're ready to roll now.
Okay, great. Yeah, so let me know if anything goes wrong. I can only see my PDF viewer right now.
Oh,
okay.
And can you tell me how to put the PDF viewer in full screen?
Well, it depends on the viewer you're using. So I'm using not a mainstream viewer. So
okay. All right.
Okay. Yeah. Hello, everybody. Hope everyone is keeping up okay at the end of this week. So this is a quick update of this piece of joint work with Jörg Ott and Timo Kekain that we started, I think, last year. So on the draft that we call Directions for COIN, so a bit trying to lay out the research field and describing a few potentially interesting topics and challenges. We just updated this draft last night, so sincere apologies. We just didn't get to it any earlier, so I don't expect you to have read this now. So just very quick reminder, so the intention of this draft is also to discuss a little bit, so what is actually so the interesting topic that well, we are concerned here in COIN. So what does in-network really mean for network computing? As we've already seen, there are different perspectives, different options. And so we're also discussing a bit, so if you say buy into the idea that you know, computing should play a more prominent role, so what are we actually talking about? So what is the unit of computation that is interesting, for example, and what are execution environments? How could you logically organize this? And yeah, so also trying to give some suggestions what we should look at here in COINRG. And so I presented this at some length at earlier meetings. I'm not going to do this again, but so one perspective of what in-network means is, well, first of all, I mean, we have to acknowledge that, well, there is already computing in the network today. So, and it's getting also more. So the way that CDNs are extending to the edge, for example, the question is how much research do these overlay systems need? So I'm not denying that. I mean, there could be interesting aspects, but on the other hand, well, there are also many people looking at these things already, and so our perspective has been a little bit to try to find other topics for network computing or other perspectives that are a bit less on the, say, engineering side. And so one perspective that we are particularly interested in, doesn't have to be the only one, is to basically try to figure out how we could maybe have a joint perspective on networking and computing. So, for example, you are aware that there are all these really interesting and also very successful application layer stream processing frameworks, for example, that are running in overlays today. So is there a way to, for example, improve performance or lower complexity by marrying them with networking concepts that we are quite familiar here in the IETF environment. So this draft, just as a quick reminder, is discussing these different types of network computing systems a bit, tries to introduce some terminology that what we'll be using in this draft, and it's also trying to characterize computing in a network versus packet processing versus, say, more familiar network computing concepts. We have two examples. So one is the CFN ICN work that I presented earlier. And so we added a new section on the ACA toolkit. That's an actor-based distributed computing system that is used in quite many frameworks. And then at the end, we are presenting some challenges more in terms of research fields right now. So the updates from last night, that's the new section on ACA. So if you don't know this, I think it's a good, say, poster child for a widely successful application layer toolkit that in this case is providing actor-based distributed computing with reactive programming, and so it's quite interesting, and it's also quite widely used. And then we added a new challenge on coordination, which is obviously a major topic in many distributed computing systems for all kinds of services and functions. Here we think that the fundamental mechanisms are actually well understood, that there has been lots of progress in that field. However, when we discuss systems, we think it's interesting to reflect so how coordination is actually achieved and what mechanisms are used, so that it kind of also relates to the system design quite a lot. And then we did some
You've got a couple minutes.
Yeah, I'm almost done. And then we did some minor fixes, usual optimizations. So quick injection here, like a bit more on the, say, general COIN direction discussion. It's actually not really pronounced very directly in the draft yet. But when we talk about computing in the network, So we think it's really more than just forwarding packets to nodes that happen to host VMs or processes. So I think this can be done already, and there are all kinds of solutions for that. And so the interesting potential, at least in our view, is to really embrace this idea of supporting distributed computing by leveraging networking concepts and mechanisms. So not just building better pipes, but trying to maybe also take a step back and think about redesigning systems. And in that context, for example, we don't really think that, say, enhancing TCP to, for example, support network computing, I don't think that a very promising direction. So first of all, it seems kind of incorrect from an end-to-end semantics perspective. And you're also inheriting much of the constraints that the TCP flow, end-to-end flow model incurs. Security-wise, it's a problem. These things will get more difficult when QUIC is deployed. So we're not sure that that's a good direction for a research group like COINRG. And finally, suggestions for COIN. So let's try to develop a good understanding about the different approaches. So it kind of showed up in the previous presentation. So there are probably really different perspectives on network computing, and maybe a first good contribution from this group could actually be to categorize this correctly and build some kind of taxonomy and really be a bit more, say, specific what we're actually talking about. So we're not saying that, for example, our perspective, that the one that I talked about earlier, is the only interesting one. But I think it could be a problem if we kind of treat this all as the same thing, whereas actually the perspectives and approaches are quite different. So that could be, I think, a good contribution from this group in the first place, and then also really understand where we actually need new research. And so that's our kind of little suggestion for the group. And for this draft, so we have a.
And so you're beyond time, so if
okay.
you could.
So this, I just keep this for your reference. So there's quite a lot to do, but I think we have ideas what to do here. So question to the group and the chairs. What do you think about this activity? Is that useful? So is it a good basis for framing the scope and directions? What should we do with this? Thank you.
Thanks, that was terrific.
Yeah, it's terrific. Before answering your question about your future of the track, we have two people in the queue. So Uma, you want to talk?
Can you hear me?
Yes.
Okay, so it's a great presentation, Derek. I think you laid out very nicely the overlay scenarios where network activity is happening today, but I am not clear what is the underlay scenarios, right? So can you describe more what are the striking applications? So are you looking for the scenarios where like active network kind of thing where the compute is required, where with the header processing or something like that, or what are the other key scenarios in the underlay?
Yeah, so I mean, the draft itself is describing like different approaches or different ways how one could perceive in network computing. And the one alternative that we are most interested in is trying to look into distributed computing and see how that could be improved by moving it from a pure overlay approach to a better integrated system with the network, and or at least leveraging concepts and mechanisms from networking today. So again, this doesn't have to be the only perspective. We also have work here in this group on, say, other ideas, say more on data plane programmability. And so what we are advocating is more, let's really be specific on the different approaches, and to don't mix them and then thereby ignoring the different properties. But have this taxonomy, and then having that, we can probably find out and discuss whether there are commonalities and make sense to maybe develop common concepts or not. But I think we have done a good start to some extent, but I think that we could kind of do a bit more in this direction.
Okay, thank you.
Yeah, thank you.
Interest of time. I think in the interest of time, though, we should probably move the rest of the questions to the mailing list.
Okay, but I think I would like the group to know that this has been one of the drafts, this one and a few are coming after, which we, in the future of the draft, that we would like probably to adopt as a RG draft. I know the doesn't really work, so we won't do that, but we'll send it to the list. But this was one of the candidates for RG adoption, and I think we will ask the question to the list very soon after this meeting. Thank you, Dirk.
Okay, thank you, everyone.
Next is Eve.
No, I think it's Michael.
Oh, it's Mike. Well, it's
Mike, are you here? Oh, there he is.
Yeah,
Okay.
I thought
are
you were going.
able to display?
Yeah, I thought you were going to present for the three drafts, but yeah.
No,
so now,
I am not.
Okay, so now it's the whole data discovery group, and yeah, Mike, I'll let you present.
Okay. See everything okay?
Yes.
Great. So this is a new draft. We have a couple other drafts that will be shared after this one that goes into specific detail on different deployment type scenarios. But the 5 of us have been working on data discovery type of research for the last year or so. And we decided to back up just a little bit, create a new draft. We think it should be necessary to discover an overall problem statement of data discovery. And then there could very well likely be several related drafts that go into specific areas. So what's the problem? The problem we see is locating data in a standardized way, and perhaps using COIN concepts. There are many existing ways to find data that are proprietary. AWS has their own ways to find data. They have some good solutions like Macy and others, but we don't know of any standardized way of being able to do so. And this data may be cached and copied and stored in many locations throughout a network. En route to its final destination, it may be at its final destination. It could be locally, it could be in a cloud, it could be in a variety of ways. And so we are researching standard-based solutions to discover where databases exist throughout the network and where the specific data objects are located. The location of each data store is probably the first level discovery problem, and then the details of the database's directory is likely the second level discovery problem. And since as I mentioned, there'll be several data discovery drafts, including some that will be presented right after this one, we created this more general problem statement, which serves as an anchor to the overall topic without going into any specific details. And if we do wind up jumping the fence over to the IETF someday and we request a BOF, then we'll be ready with this problem statement. This idea did evolve out of an edge computing side meeting. We identified many different gaps in that side meeting, and edge data discovery was one of them, and that's why we're even talking about this. So right now we have 3 related data discovery drafts. This one, we have one that Eve will be discussing after this one that's edge specific. And there's also a new mobile related data discovery draft. And there's other ones that we may want to be specific to ICN or any other type of a solution. Just to give you an idea of kind of how this all started, there was a variety of use cases that we identified. The elevator use case was one of them, where you've got hundreds of sensors on an elevator, and it's sensing all sorts of things from vibration to temperature or whatever. And that data is being sent to different places in the network. It could be on the edge, it could be in the cloud, it could be dynamic in memory. And that data needs to be discovered and searched in a certain way that's in some cases very granular and also in a standards based way. So what's next? We need to determine if existing protocols will work to solve what we want to have done. If not, then we need to target where a new standard protocol is needed to discover data. And maybe, again, we continue to work on it in COIN, which does seem very reasonable, or maybe we try to create a BOF. And so that's where we're at. Any questions?
Okay, well, if there are no questions, then maybe I'll just go right into my, oh, Marie-José, do you have a question?
Yeah, I do have a very fast question. Mike, you talk of a BOF. You're talking of a BOF in IETF or a new research group?
We don't know, and we just floated the idea that I didn't even know there were BOFs in COIN. I was thinking about IETF.
So to really have a working group on data discovery?
Maybe.
Okay, no,
Yeah.
it's a question. Thank you.
Thank you.
Okay, I think I'm next. Are you able to see my screen? Can you hear me? I'm not hearing anybody. Can somebody, and I can't see the Meet Echo.
If we can hear you and we could see your screen.
Oh, thank you. Thank you for the confirmation. I was just going to go back to the other screen. Okay, let me be quick because I'd like to leave a little bit of time for the last presentation, which is all new material. I'm Eve Schuler, and so this was the original draft that we came up with.
Now your screen has disappeared.
Oh, okay. Let me go back to the Meet Echo and start displaying again. Okay, how's that? Can you see it now? Okay, great. Let me be quick then. Because this is, you've heard about the problem. The way this relates to edge computing, of course, is that the more compute in the network, the more the data gets distributed and is dispersed because it's created processed, stored, and so forth. And so it is sort of scattered. The way this relates to COIN, of course, is that computation often requires data input and results in data output. And so this is why this is relevant. One of the issues that we had was we felt like we still have a somewhat anemic references section. And this is why Mike went off and started looking at related work and discovered that, maybe there's a more general problem here. But in terms of this draft, we had just a couple of tweaks. We did some clarification to the use case that's service function chaining, and then we added a use case that we have affectionately referred to as ubiquitous witness, which is the idea that in dense IoT deployments, there are many, many cameras and sensors. And so when an interesting, unique, or unusual event occurs or an anomaly occurs, that there are many sensors, cameras, etc., that witness it. And that's why it's called ubiquitous witness, because there's dense sensing. So we added that case here. We also began, have the very beginnings of a security considerations section and acknowledge those who've given us feedback. We also have added a new author, Diego, who's joined us. There were some really detailed edits that Greg Skinner contributed to the list, so I thank him. The interesting bits about the ubiquitous witness use case that were added is that data is, because it's location driven, these witnesses are all within some interest region of each other, and are typically reporting on something within some small time window of each other. The data is all contextually related, and that as data comes in, if you want to somehow find it, given that it may be scattered at all of these other devices or in multiple places, that you may need to name your data so that you can subsequently search for it. And furthermore, that at these collection or aggregation points, the data may, because it's contextually related, you may be able to process it collectively. And you might want to do that before you pass it further up or to other places. You might want to, say, stitch your video together or reduce the numbers of data streams that are reporting on something to only the best, and so forth. In terms of the security, as I said, the function chaining is all about clarification, but the security section was mostly to acknowledge that what we are expecting is that data will have associated policies that will make discoverability a function of these access controls, and that we also stated that the assumptions around whether or not all edges or edge clouds share their data or make their data public should not be an assumption, nor should the assumption be that all clouds are somehow keep their data private. And so again, very modest beginnings, but a beginning for the security section. And then after we published, we received some additional comments from Leisha around data provenance and further definitions of edge computing that we expect to add to the next version. So I think with that, I'm going to hand over the floor, because we don't have that much time, except I'm trying to figure out how to, this is always elusive, how to stop sharing. Okay. All right. So I think, Xavier, if you would like to take the floor. Oh, I guess we should see if there are any questions. Yeah. Okay. Xavier, are you there?
Yes.
You are. Terrific. All yours.
Thank you, Eve. So I'd like to discuss the impact of mobility on discovery in COIN. So mobile devices can be service, data, or resource consumers or providers in COIN scenarios. And those scenarios are typically distributed and dynamic. So here are a few examples. Mobile devices can generate video or data streams that are processed at the edge, for example. And mobile devices can also be used as edge computing platforms, as studied in a recent study item in ETSI. So this draft discusses some challenges on discovery associated with wireless mobility to provide some input for the current work on discovery. So a first set of challenges is related to scalability. We need to keep wireless resource usage low per mobile devices. And also there are a few additional considerations, like multicast is expensive on wireless networks. And in dense areas, mobile devices can generate a constant level of traffic, from churn. So as examples of mechanisms, to provide some context here, we have pre-attachment discovery in 802.11aq, published in 2018. And we have also edge computing discovery in 5G, which is a work in progress. So just to go a little bit in it shortly, at least for the first stage of discovery, which is what we care about most for the mobile context. A mobile device provides some information to a discovery service in the control plane or in the mobile operator's network. The request includes some information like application client type, expected location, requested QoS, and others. And the discovery service provisions the next stage discovery server on the mobile device. So that is specified as a data network name. So because that next stage server is in a data network with the other application servers, and a URI to connect to that next stage discovery server. So then, the mobile device can basically establish the data plane connection and continue discovery, right? A mobile device also needs to determine which network interface or data network to use for initial discovery or when relocating. So a mobile device may need to choose between connections not yet established. Right. So as in the case we just have seen in the previous slide, for centralized discovery in a managed network, a control plane server can tell which data network to use. Right. Now for a more distributed discovery method, we can use passive and active discovery methods. In the passive discovery methods, we have provisioning domains that exist, router advertisements, DHCP signaling. And those methods, typically need the data plane connections to be up unless you can provide them, prior to that time. So, for example, provisioning domains could be deployed using policy rules, but that is not done today. And active discovery methods like DNSSD or MDNS can be used as a second step, or basically can be also used concurrently over multiple interfaces. And finally, the service continuity needs to be maintained when a provider or consumer moves to a new location, and that can impact the service level. So for example, you could lose frames when processing a video stream when a mobile device moves, for example. Now, strategies, among very common and high-level strategies, we can reconnect to a same service instance, after moving to a new access point or data networks. We could reconnect to the same instance, actually migrate or use multipath, or basically you could also discover a new instance and use it concurrently or as a replacement. So one question is, could this discovery process help inform this choice of strategy for session continuity? Right. So to conclude, and as a starting point for a discussion that we can have after, we could consider mobility-related requirements, among others, for data and service discovery in COIN. We could, plan to support, centralized and distributed schemes, as well as, control plane and data plane-based solutions. And we could also leverage or extend existing standard solutions to reduce mobile network resource usage. So thank you for listening and for any feedback that you may have. Thank you.
A question from Dave on the chat about this. I don't know if it applies to this presentation or the previous one, but I think it's all related. The description, the distinction between in the network and on the network. Does anyone of you want to comment on this? Also, my question while I'm on, Xavier, is it's not clear to me what are the research elements in your presentation, and I may have missed it. So two questions, one between the distinction between N and on the network, and the other one about what are the research challenges?
Okay, so yeah, on the first question, maybe I'm not sure if I have any input on that, so I don't know if Yves wants to answer.
Oh, I'm sorry, Marie Jose. I was looking at the Jabber window. Can you repeat your question?
There's a question from Dave. It's actually the question about being in the network and on the network.
Oh, and I think it was recent, so I'm assuming, Dave, it was about this current presentation. That was what I was just reading, actually. I'm going to read it out loud since Dave doesn't seem to have audio. Clarification, question, comment. We seem to not have a crisp distinction between in the network and on the network. I'm having a bit of difficulty teasing out which is which in this draft. I presume that you are talking, since this came in at 8:02, to the current, to Xavier's draft, and more generally, does it matter? My intuition is that it does matter, so not excluding stub endpoints in the absence of some distributed computing elements involved in the communication seems a big expansion of the scope of COINRG.
Yes.
Not excluding stub endpoints.
Well, I think also, Eve, it's related to the next question from
Dave.
Lars.
Okay, so
Lars
Dave
about,
looks like he can have, he can speak now. He's got audio. Is that what Alicia's telling me as well?
And also there's Lars who has a question.
Okay, can you please convey, and I'll stop looking at the Jabber window. So I'm not sure I understand Dave's question, unfortunately.
And actually, I think the next one, I can actually ask Lars' question. Oh, here's Lars. So go ahead, Lars.
Okay.
And there's Lucia. No, here's Lucia.
Go ahead, Lars.
I'm a bit confused by the last few presentations, and I must say I haven't really paid.
Can you speak a little louder?
I can. I'm speaking pretty loud, and it worked before. So I haven't really paid much attention to COINRG since it got chartered, but I'm so surprised that the scope seems to have ballooned quite a bit from what the charter talks about. And so I thought the intent was to figure out how programmable network hardware that can operate on data is sort of, best used in potentially in a future internet. As a summary of what I thought the charter was sort of talking about, and the last few presentations were looking at completely different things, right?
Yeah.
And I think that maybe is a little bit also what the direction which Dave is going, who I think has been saying that it would help if you basically excluded what the endpoints can already do, like general purpose computing, from the discussion, right? Because that is already covered elsewhere. COINRG, the novel part is like this whole notion is how do you leverage compute that exists in the network, so not in the traditional places.
Yes, and I think that as a result of the in the network issues, this is why marshaling data from somewhere and figuring out where to place data after computation, and if it's persistent, the output from computation, is really what the original edge data discovery draft was about. So it was kind of this ancillary but attendant problem related to the fact that compute requires I/O. And then it's kind of, and then the other two drafts are new.
Yeah, so that confuses me, right? Because maybe I'm from a different world, but where our customers, right, they're basically laying out pretty carefully what the data pipeline is going to be between the edge and the core and then the cloud, right? And so the idea that data would sort of float around and you'd have to find it is kind of weird, right? Because that's not how it works.
Sure, if you have a container-driven orchestration model on what compute in the network means, then sure. But even containers, the persistence of data beyond container sessions, or even optimizations for containers that might use the output from previous computations and so forth. Again, like those things may live.
What data storage exists, right? It's not
I'm sorry?
That's the purpose of data storage, right? That you're dumping this persistently because you want to reuse it. And I have a visitor. Hey, I need to take the call. Yeah, awesome. Somebody got a new dinosaur book. So you don't, if you run a container, you not just like let the data sort of dissipate into the network and then you sort of hope that you will find it again in the future. That's like seems pretty suboptimal.
Again, you have a container model, about where the data originates and that everything is pre-configured. But if things are happening on the fly, you know, so the example that I gave about ubiquitous witness was that data is coming through a programmable switch, let's say, and it recognizes that all of this data is contextually related, and it decides to do a computation on it. So it was not, so maybe this is something that through AI it discovers. So it's not container driven. So that was kind of the counter argument to that it's not pre-configured. But we are running rather late in our, that's okay, and there are a couple other people in the queue. Marie-José, I'm gonna leave it to your, let's continue that discussion, because I think it's good.
No, we should take the question. Licia. And then we'll take Torless and close the queue. Hi, Licia.
You can hear me.
You're a little quiet.
I understand how the asynchronous communication is difficult, because this discussion is a bit async. I wanted to answer the early question. I think Dave raised up about in network, on network, or above network. Fundamentally, it seems to me it's a namespace question. If computation wants to be in the network has to recognize what that is. If the network only recognizes addresses, this was a debate I was having with Lars on the Java. If you only recognize network addresses, you cannot see computation. So that's where the question is. I'm done.
Okay.
Okay. Torless?
So maybe, you know, I see it, I know it when I see it approach in terms of trying to find the most simple examples that are felt, you know, in the way that says it to be within the scope, and the closest one that wouldn't be within scope, right? And so the explanation about contextual data, right, the way I would phrase it as existing networking things is there is all type of DPI that is spoofing on traffic and could then establish, you know, even changes to the traffic, like in firewalls, in inspection units, and so on, right? So that's an existing interface between fairly rich computation and the forwarding plane, right? So would that be in scope or out of scope? So just come up with examples and then beat it up, what's in and what's out.
Thanks.
And
Okay.
just a few words to answer to Marie-José's comment on the research aspect here. You know, I think like you know, the mobile use case, actually, or mobile device use case, adds this additional first step in the discovery process, where you provide some information for the device to decide if it wants to attach or not, or if it wants to connect to that network or that other network, because that's kind of an expensive operation. So maybe one difficult aspect would be to determine what type of data especially for data discovery, what do you provide to the mobile device so that the mobile device can make a decision to connect to that AP or that other AP based on, you know, the fact it needs to access a certain type of data or a certain data.
Yeah, but Xavier, I want to go back to Lars's comment, is that doesn't really need any computation. I think let's take a note for everybody, and I'll when we do the minutes, that it would be really good for presentations to go back to the charter and say what part of the charter they address, because if not, I agree that we're going to touch so many things. Doing plain data discovery and finding which point of access to connect to, you don't need any computation for that. You would need computation if something is needed in terms of computing a position or computing the best the best path to the best access point or something like that. But the way just to find where the best location is, yeah, I don't think you need computing and a network for that. So I don't want to sound mean. I think the work is valuable, but I think it would be, yeah, a big step backwards, everybody. How do we connect to the charter? And maybe going back to what Mike was saying, maybe if there is such an interest in just discovering the data independently of computing or not, then maybe, yeah, maybe you need another, maybe it's a BOF, or maybe
it's separate. Okay.
It's maybe
Well, let's
it's
take this
something
to the
separate
list.
from our list. I don't know. I don't want to throw anybody out, by the way, because
No,
that's
this is
not my
good.
role.
But we are very far behind, so let us keep going. We've got a little wiggle room at the back end, but not much. So
That's fine.
thank you very much, Mike and Xavier, for this. And Ike is in the queue, so let's give him the screen. And then there you go. Okay. We're not seeing your screen yet.
Do you see something now? Can you hear me?
We can hear you, but we cannot see your screen yet.
Okay, then let me try again.
Okay.
So
Something's happening. That's a good sign.
yeah, I got a selection folder, but I don't see the screen that I want to select. Let's see. No, it doesn't seem to work. Can perhaps somebody else share my my slides? So I see the PDF viewer, but if I select that, you don't see anything.
Okay, let me see if I can grab them. Let me take me a moment.
Maybe you can start talking, Ike, and then we'll figure out the slides.
Yeah, sure. So I will be talking about the progress that we're doing regarding our 3 drafts. So the industrial use cases for the transport issues off, and the security and privacy enhancements with network computing systems. And yeah, actually since March, we haven't really updated the drafts, but we have instead more or less focused on working on the topics. And yeah, what I would like to do today is give a brief overview of what we are currently doing and what we're still planning to do. And I also, so somewhat related to what Marie-José was saying in the beginning, like the scoping of the research group, and then also related to what Dirk presented.
Can you see my screen, by the way?
Yeah, that looks good.
Yes.
Could you go to slide 3, maybe directly?
Okay.
Yeah, so I also.
Where was I here?
Yeah, go to the next one. Yeah, to this one. Yeah.
Okay.
No, slide
Great.
3. Yeah, thanks.
There's no numbers.
Okay. Yeah, but that's the right one. So I was also thinking about how we could perhaps scope the research group a little bit more, or how we could help with that when we're doing like the research group drafts that we were discussing earlier as well. So yeah, the first draft that we did was about industrial use cases. So here our basic assumption was that we have a lot of sensors and actuators in industrial systems. And then depending on the concrete setup, it might be the case that there are simply too many sensors transmitting, for example, into a remote cloud, and then not all of the data can really be transmitted because the uplink capacity, for example, is too small. Or if we have actuators which need to have low latency control information, then latencies might be, or physical latencies might be too high to ensure certain low latency applications. And our idea in this setting was then to deploy certain functionality into the network so that we can actually enable these settings in the industrial environment. So for example, thinking of this latency critical applications, if you take a look at the image there at the top, if we simply place a functionality at the top switch there and don't have to go all the way to the remote cloud, then some control information that can be derived from sensor input might be now fast enough for the actuators there on the left side. Next slide, please. In this context, we're working on quite a lot of different prototypes, and this is one example use case that we're doing. So if you take a look at the image on the left side, you see like this red thing there that is laser tracker, which basically measures or tracks the position of this vertical thingy there with the checkered field in front, and it measures this the position in the form of spherical coordinates. And what is then done is that these measured coordinates are transmitted into the remote cloud actually, and there they are mapped into a global coordinate system, and then from there on transmitted back to the actual vertical thingy in the form of Cartesian coordinates. And yeah, there our mechanical engineers tell us that that is too slow for their applications, and what we are thus instead trying to do is execute these functionalities directly on the networking hardware. And it then basically boils down to the computations that you can see on the bottom right. So a couple of trigonometric functions and some multiplications. But this is in fact already too complex for most networking hardware, which is why we are now currently looking at different ways how we can express that, or how we can express that on networking hardware. And there we are currently in the evaluation phase, and soon planning to write a paper about that as well. Next slide, please. The next draft that we then did was on the transport issues. So in general, we have that applications build up a dedicated end-to-end transport connection when they want to exchange data, and they then especially assume that the network underneath is unreliable and doesn't really touch the content of the packet that's going through the network. We with COIN now, however, somewhat break that. So I think Marie-José also said that in the beginning as well, because now some applications, or as I showed on the previous slide, we intentionally try to fiddle with the content of the packets, and thus somewhat introduce the need to have a notion for transport sensitivity also in the middle nodes there. And in this context, we've then raised a couple of issues in our draft. And now we've just started to do a first prototypical implementation for a transport, which is able to support and understand changes that are happening in the network. And so we've actually really just started like a month ago, I think. And what we are there currently trying to, or what we've chosen there for a beginning, is a IPv6 as the addressing schemes, so that we can then on one hand set distinct IP addresses for each of the functions that we have in the network, and then can make use of segment routing to steer the traffic so that all of the functions that we want to have get executed. And then we've decided not to reinvent the wheel, but we've instead opted to use an existing transport mechanism. And there we've thought about using SCTP, because it is a datagram-based protocol, so that we can make sure that the packets that we have in the network are self-contained. And additionally, SCTP offers the nice feature of that the messages are made of chunks, and there are quite a lot of so-called chunk types that are still reserved for IETF use. And what we are currently intending to do is that we want to experiment with assigning certain chunk types to certain functionality in the network, so that then based on the chunk type that is used by the sender and and then received by the receiver, both participants then know what the network will do or has done with the packets that they receive or send. But that is, as I said, still really early stage work. Next slide, please. Then our final draft is on potential security and privacy enhancements using in network computing systems. So this is again rooted in our industrial background, so that we see a lot of legacy devices which are hard to update, and they commonly don't feature any security or privacy mechanisms on them. And yeah, especially if you have critical infrastructure there, sensitive data and processes may be leaked to the outside. And we are now currently, or rather my colleague Ina is currently experimenting with the potential of retrofitting additional protection mechanisms using in-network computing. And one thing that she's there currently taking a look at is the manufacturer usage description, which basically gives us the opportunity to define what kind of traffic patterns or traffic behavior can be expected from certain devices. And then based on rules, we can check whether these patterns are actually fulfilled by the end host, or whether there are some anomalies in that way. And there she's currently trying to, or evaluating whether we can enforce the even more sophisticated rules inside the network using P4 switches. Next slide, please. So this is then actually also the last slide. Our next steps are that we want, of course, continue our work, especially the one that we've just started. Whenever we find something that is valuable for the group, we would like to update our drafts accordingly. And we are still also very much looking forward to feedback from the research group, especially for our rather new drafts, so especially the security and privacy draft. So yeah, please feel free to take a look at it and give us feedback, and we'll be happy to add it to our drafts or update our drafts accordingly. And then the last point that goes rather in the direction, as I said at the beginning. So what Marie-José was also talking about, what Dirk said. So I've thought a bit about, if I would be someone from the outside looking at COIN, would I directly know what we are doing, or would I, just maybe also just like Lars, have a problem of really understanding what we're doing? And in this context, I've really found Dirk's draft, or Dirk's and Jörg's draft, really helpful as a basis, because they tackle the question of how we understand COIN, what kind of different meanings for COIN are there, and thus I would really support if we potentially extend that draft to make that maybe as a basis for the research group, so that we can align all the other research around such common definitions. And I would also potentially have something where we also include general definitions that we want to use, because I think in a lot of ways we are often talking about similar things but using very different words for them, which obviously makes it more difficult to understand each other. And thus I would appreciate if we could maybe think about that for further drafts. And I think that we leave the rest off here due to time constraints, I guess. But thank you. And if there are anything, or if there's anything that you would like to discuss, I'm happy to take questions if time permits, or on the list or via mail.
We probably have time for a question, if there is one. And I will queue up the next slide, since I think I'm also displaying those.
Actually, I would like to thank Ike for the last slide, because it's nice to see them organized. And obviously, again, the data discovery, I think, is something that we need maybe a little bit to realign. But thank you for the last presentation. So are there any questions? I'm following the discussion on the chat, and I'm not seeing specific question. Does anybody have a specific question? Yes, Stuart, we can take that to a private discussion. Okay, the last two one is me and Eve. So this
not
is
just us, others as well.
Yeah, no. Well, I mean, it's us and us and the ones that are there, because I don't think Roberto and Edgar made it. They're on vacation. This is something that actually comes from the charter and has evolved not from the top down, but from the bottom up. Next slide. So obviously, this is actually something that you, Eve, said before. The network is the data, and I've been working for quite a while now on data-driven services and application, and the fact that there's a lot of delay-sensitive and critical decision-making that needs to be done close to the location of that data gathering, which is much beyond what is usually done, where you gather the data, you send it on your Wi-Fi network, and you send it up to the cloud, and things are all done there. I think Ike will agree with me that in industrial applications and a lot of edge applications that are delay sensitive, like AR, VR, and others, there's a lot of need to do things locally. And there's also more and more a recognition that there's AI and machine learning applications that are what I said at the beginning, are these combinations of local edge and cloud computation, and they need not only cloud computation like on things that are attached to the network, but things that are part of the network. And so this cloud edge continuum, and there's this powerful hardware, the Tofino switches and a lot of software abstractions that are now available in IoT and edge computing. And we started mixing all these things together, you know, the Tofino, which does a lot of the match action that is very, very interesting for data filtering. And Eve and I have had discussions with the Intel people who are part of the Tofino switch, where we also wanted them to start doing match action on metadata and not just on header addresses, so that we could have better edge computation systems. So next slide. So it's too small and it's too complicated, but I think what this thing says is that
I can size it.
You
can you
make
see
it
that?
bigger? Okay. There's actually a lot of things in there, including there's PubSub that actually can drive, and this is why we want to start doing things on the metadata, PubSub or even ICN-based applications that want to identify the packets that are interesting. Filtering, there's obviously data acquisition that can be in multiple locations, and there's actually cloud and local processing for that data. And again, you need to have some of that processing done not on the network, but in the network for it to be very, very efficient and being able to support these critical applications. I will tell you that the first time that I thought about this was actually in a vertical agriculture application, where there's a lot of local decisions that are made based on the type of images that you have, and you make decisions based on what you see, and what you see has to be determined. Then the decision has to be determined and by local algorithms, but then also the results have to be filtered depending on where they're going. So if it's something that can be resolved locally, it is sent to a local processor. If it's something that is much more related to overall management of the system, then it's sent to the cloud. So the idea of having this common data layer is to say, okay, what are the elements in terms of hardware and in terms of interfaces that we could define that would allow these decisions to be taken both locally and in the cloud, and to have the processing done both locally and in the cloud in collaboration with networking in the middle to allow the communications between the different processors, and also with the different, I call it data networking mechanisms, which is related to ICN, by the way. Next slide. So I'm running out of time. So there's actually data layer functions. I mentioned the filtering, the pub sub, actually there is a service data function discovery. There's orchestration. There's cache management, which works with the size of the cache and the staleness. Yes, I'm seeing Jörg's question. Discuss network computing devices. Yes and no. Actually, also it discusses what's inside the network computing devices, and that's what we want to go actually more into. So anyway, so this is all the functionalities. There's a lot of other people who are looking at this, and we want to make sure this is very early work, by the way. And there's a lot of other people who are looking at similar things. We want to also allow, and this is actually for Jörg, we want to be able to allow in that layer to do pipelining of functionalities and do pipelining of decision making. So there's a lot of AI and ML in there, but I take the point that it does, yeah, if you take it to the simple layer, it could look like just doing network computing devices, but we want also to do, I would say, computing device in the network and not on it. Next slide. I guess that's going to be a theme now, the difference between in and on. No problem, Jörg. And okay, so we wanted, this is actually very early work, and I think one reason we wanted to expose it is because it's related to automotive, as cars are becoming way more, the car is the network now. I mentioned agriculture 4.0. There's a lot of next generation IoT, which includes a lot of intelligent controllers that do local functionality also. We want to look at solutions that we've looked at and maybe prepare a draft. It's related to work that's been done in Ericsson, so that's why we have authors from Ericsson. And because there is an element of discovery of capabilities, of functionalities, and of data, that's why we feel it's related also to the data discovery. So this is very early, but I know that there's other groups who are looking at adding functionality in terms of match action and filtering using header information, and more than header information, you know, like network layer functionality that is based on what I call match action. So we wanted to expose the work, although it's very early, to make sure that, you know, people know that this is actually, and this is actually within our charter. It's actually the part of the charter that we need to work on. And so we wanted to expose it. So thank you for listening to something that's actually still very much in the becoming instead of in the coming. I'm following the discussion. It's actually, there's a lot of coded computing and homomorphic encryption and all kinds of network coding. I think, again, we can take that offline. Eve, you want to conclude?
I think I need to bring back up the slides. So why don't you start talking while I navigate the MEDECA.
So,
and I apologize, I didn't realize I'd be presenting at all any of these slides, but Marie-José ran into technical difficulties, so my apologies.
Okay, so that's it. We're at the end. Yeah, the end is near. So obviously, there is work to be done. I think, thank you to all the presenters, and thank you to people who have participated on the discussion that I'm looking at still. We want to, again, start adopting some drafts. And that was a previous one. And
right. Sorry.
Yeah, and I think we had a few candidates. I think right now the top candidates are Dirks and Ike's. We'll push that to the list to ask, you know, I'm actually doing two things at the same time, so I'll start focusing on what I'm saying. So we want to start adopting, and those two are the top ones. We'll send it to the list. We want to have an interim in late September, again, for document management and make sure that all the documents are progressing. There's also potentially new research topics because there is a lot of work being done into what I call in the network and not on the network. And maybe we want to have some invited talks. I'd like to re-invite the people from Cambridge University, for example. Okay, so there's a security discussion on the side that I will ignore for the moment. And then, so I'd like to re-invite the people from Cambridge, Noah Zilberman and company. And there's other work that's been done out of California that I think would be, and Stanford and Berkeley, that could be quite interesting. So I will probably, and we will chase that.
But I would invite the folks who are having a security conversation to maybe pipe up. We have until 8:50, so we do have 10 minutes.
So the people who are doing the security discussion, Stuart, Dirk, and Dave, would you like to, you're the current invited talk, would you like to say something? Okay, somebody is asking. Okay, Dave, it's yours.
I don't have anything now, but I would like to enter a conversation on the list, perhaps.
Okay.
On the topic of?
That's Stuart. That's actually, it was security and encryption and homomorphic encryption. Dave? Dave? Okay, Dave is having problems. Okay, so you keep dropping. So I'll read what you sent. Dave said, just to throw a final monkey wrench, there are 3 possible approaches to security. Figure out how to distribute the key to all the possible intermediaries while controlling transitive, trust and provenance. Depending on FHE, provide a shim layer to migrate the things you want to operate and to be outside of the encryption envelope. I think this has to go with like when you start putting computing in a network and the packets that are coming are very much encrypted. And yes, Licia, this becomes a question of trust establishment. And I think way back when, you can talk, Licia, but I think way back when we had talked about when you start putting computing in a network, you start needing trusted entities. Licia? Licia?
Yeah. I think there is like a 30-second delay after you allow me. To me, actually, I think the fundamental question is really trust establishment. Different from what we do today on the internet. We somehow ignored how the trust get established. We think that there are the CAs out there that take care of that question. I think for this edge computing thing, I think we have to take a fresh start after that question, because if we think that there will be lots of edge devices, where do you get the trust for them? They don't have, I'm pretty sure nobody gonna pay them to get the commercial CA certificate. Now, do you trust the certificate you get from Let's Encrypt? So the big questions out there. I think after we have trust the establishment, there are existing proposed solutions, how you can manage, answer all the other questions I think Dave brought up, like a key distribution in an automated way rather than manually configure or something. But the first thing I think is the most difficult, and that.
And actually, I would like to encourage folks, given that we have been running in tandem with the Applied Network Research Workshop, that, to kind of think of these IRTF working groups in that vein, in that we really were given the directive to bolster, these discussions around security, privacy, and trust. And if you hear or see, a presentation or a paper about computation in the network that has an interesting, reasonable, provocative, name your adjective, description about security, privacy, or trust, let's try to invite those speakers here. Let's be more active in our pursuit of those who are working in that arena. So that was kind of my takeaway of what's lacking here.
Okay. And since we have Dirk on the line, I think there's also some of the discussion that happened inside the distributed
the DIN RG.
DIN RG, and with blockchain and Ethereum spaces, that is also quite relevant, and something actually what I did not present in the data layer is that we're also looking at that to at least created the network of trusted entities that are collaborating together. So this is more stuff. Thank you, Alicia. There's okay, Dirk, go ahead. Dirk? Okay, we lost Dirk.
This is a strange system. I'm still here. I cannot mute myself. And you have not enabled the Dirk yet. You haven't enabled the Dirk yet. So
okay, so now you are revoked. Okay, and then okay, Dirk, you should be able to talk.
Okay, yeah, thanks. Yeah, I just want to say I'm not sure it's a good idea to mix all these topics together. So I think from the discussion today, also in the chat, we have, I think, learned that there's quite a bit of scoping and clarification to do. And so, like on network, in network computing, these kind of things, this taxonomy that we talked about. So let's not broaden this even further. I think that could be challenging.
But also, I think that your point is a good one with regards to maybe the interim focuses on, we pick a topic and we focus for our
and
interim.
I think we have DIN and we should take DIN, and I think we should not be afraid of sending some work to the other groups when we feel that it's outside of our own scope. We have a lot of related research groups. We have Things to Things, which is related to us. We have obviously distributed networking, which is related to us. We have ICN that is related to us. And I think we should not be afraid of either sending work out or actually doing joint work, so that we do not duplicate what is being done elsewhere. So now we have 2 minutes before we're actually shut down. So I have the impression that 108 will be virtual. Do we want to do a hackathon? I don't know. The experience from last week was halfway good. Actually, Gathered.town was kind of fun for it, but I don't think we made a lot of progress, by the way, in the one that I was in. So we can talk about that at the interim. Now we have 1 minute. Thank you, Eve. I'm sure Jeffrey.
Thank you, everyone.
Is really sorry that he couldn't join. He had really computer problems. I thank everyone. At one point we were 78 people, which online is amazing. And thank you very much for everybody for participating. Thank you extremely more particularly to all the presenters and the people who've done the great work. I think we're going to be sadly virtual for a while, but I'm looking forward to the day that we can again meet in person. And in the meantime, wherever you are, please be safe, be healthy, and let's talk again at the end of September.
Thanks, everybody.